Hello and welcome back to the next video. In this video, we are going to discuss pointer arithmetic. So we can perform only certain arithmetic operations on pointers. We cannot perform all the arithmetic operations on pointers. So what are those operations which we can perform on pointers? The first operation is called as addition operation, right? So we can add an integer to a pointer like this. Let's say p is a pointer. So we can add this integer n to pointer p. For example, let's say n is equal to 2. So we can say that p is equal to p plus 2. So this p is a pointer. We are adding integer 2 to p. So that is perfectly allowed. But what is not allowed? Let's say we are saying p is equal to p plus p1, where p is a pointer and p1 is a pointer. We cannot add two pointers, right? So that is not allowed. That is invalid. Now what happens? So this is valid. So what happens when we add an integer to a pointer? So for example, if we add 2 to this p, what happens to p? So if you add integer to a pointer, it moves the pointer forward in memory by these many bytes. Now how many bytes are these? So let's see this. So first of all, let's understand this size of. So size of will calculate the size of the data type which you pass to it. Let's say it's a function, it's a inbuilt function which will calculate the size of this type, data type which you pass to it. For example, let's say type is int. If you say size of int, it will return you the size of, means the number of bytes required to store this type of data. For example, size of int means number of bytes required to store integer type of data on that machine will be calculated by this size of. So for example, if we are on 64-bit machine, size of int will return 4 bytes because integer requires 4 bytes of memory. Okay, so size of int will return as 4 byte. Now so this addition of integer to this pointer p will move this pointer in the forward direction in memory by these many bytes. So now here, the size of type, what type we are talking about? We are talking about the type of a pointer here, right? For example, if we have integer type pointer, so this type will be int. So we are talking about the type of the pointer. So type of the pointer here is int. P is pointing to an integer variable. P is storing address of another variable of integer type. So this will return as 4. So n into 4. So if we are adding n to p, so this p will move in the forward direction by n into 4 bytes. So if n is equal to 2, 2 into 4 is 8 bytes, right? So this will move p in the forward direction by 8 bytes. Now if n is equal to 3, if n is equal to 3, so this p will move in the forward direction by 3 into 4, 12 bytes. If n is equal to, let's say, 10, so p will move in the forward direction by 10 into 4, which is 40 bytes, right? Okay, so let's see an example of this here. So now let's say we have an integer variable a, right? When you declare this integer variable, this is what happens in memory. 4 bytes of memory will be reserved, and that will be named as a. Let's say memory is reserved from 4000 to 4003. We have an integer type pointer p. Now let us store address of a in p, right? So address of a we can get by saying address of operator. Address of a will return us 4000, and we are assigning that 4000 to p. So we are storing 4000 in p, pointer p. Now pointer p is having its own memory address, let's say 5000. Because p is also a variable, we need memory for p also. That's where we'll store the address of another variable. No, so that's what happened in memory with this. Pictorially we can show that p is pointing to a, but this is just pictorial representation, but actually in memory this is what happens, right? P stores address of a. Address of A means base address of A. Now, when I increment P by 1, when I'm doing this, P is equal to P plus 1, right? So what is P? P is 4000, right? P is 4000. But I'm not adding integer 1 to this 4000, right? It is not becoming 4000 plus 1 is equal to 4001. It's not like that. We are incrementing P by the size of the location to which P is pointing. Size of the location to which P is pointing. P is pointing to this location. What is the size of this location? 4 bytes. 1, 2, 3, 4. So this 1 is equal to the size of the location to which P is pointing. Size of the location is 4 bytes, so it becomes 4000 plus 1. This 1 is actually one location or a type of that memory. Type of that memory is integer. There are 4 bytes here. So this 1 is not, the face value of 1 will not take, but 1 as one location, right? And what is that location? That location is of 4 bytes. So actually we are adding 4000 plus 4, right? One location is equal to 4. So it becomes 4004. When I say P equal to P plus 1, it is becoming 4000 plus 4, that is 4004, right? Now when I increment P by, let's say P is equal to P plus 10. So what I'm doing, I'm not adding 10 to this 4000, but I am adding 10 locations of integer type to 4000. One location is of 4 bytes. So actually 10 into 4, right? 10 into 4. I am incrementing P by 10 locations. I am incrementing P by 10 locations, right? 10 locations means how many bytes are there in one location? 4 bytes. So 40 bytes we are incrementing. So P becomes 4000 plus 40, which is 4040, right? So always remember, when we increment a pointer P equal to P plus n, we are not adding face value of n to P, but we are adding n locations to P, and the type of location, it decides the number of bytes for that location. If it is integer location, and that type of location is nothing but type of pointer, right? So this location is integer type location, and that's the type of pointer, right? Pointer is pointing to that location. So you can remember it like this. We are adding n locations to P, and location means what type of data we are storing there. If it is integer type location, n is the size of the location will be 4, right? So it becomes 4 into n, right? That's what this formula says here, right? N into size of the type. Size of the type is actually the type of the pointer. Type of the pointer is nothing but what type of data that pointer is pointing to, right? So size of, if it is int, it will return 4, so it will become n into 4, right? By that many amounts the pointer will move in the forward direction. Let's understand this in with one more example. Now let us say we have character C, variable C. This is what happens in memory. Let's say C is named as, or memory at 5000 location is reserved for C. C is a character, requires 1 byte. We have character type pointer P1. So P1 is a character type pointer. So we can store address of C in P1 by doing this. So memory, this is what happens. 5000 is stored in P1. Pictorially, P1 is pointing to C. Now here, if I say P1 equal to P1 plus 1, pointer P1 will be incremented by one location of character type, right? Because P1 is pointing to character type location. So P1 will be incremented by one location of character type, right? And here one location is 1 bytes only, 1 bytes only. So P1 will be incremented by 1. So P1 is 5000. So 5000 plus one location, and one location is of 1 byte. So it becomes 5001, right? Now if we have a float type pointer P2, right? So if I increment P2 by 1, now P2 will be incremented by one location, right? And one location of what is the type here? Type is float type location. This is a float type location, and P2 is pointing to float type location. So by that type of location, so one location is 4 bytes here. So P2 plus 4 bytes, it becomes P2 was 7000. So 7000 plus 4 will be 7004. Okay. Now Let's understand this with an array. So let's take this. Now we are going to discuss pointers to arrays in great detail later, but just for now we'll see this example what happens in the case of arrays. Let's say A is an array of integers, right? So one location we can store one integer. If in one location we are able to store one integer, what should be the size of that location? 4 bytes, because in order to store one integer we need 4 bytes. So size of this one location of the array is 4 bytes. So this is 4 bytes of location, 4 bytes, 4 bytes. Every location is of 4 bytes. Let's say the starting address is 4000. So this location will have 4002, 4003. The next location will start at 4004, so on and so forth. Now let's say we have a pointer p of integer type. It can point to the integer type data. So now every data here is integer type. So I can store address of these integers in p. So let's say we want to store address of a0. This first location is called as 0th location, and I can access that by saying a of 0. A of 0, that in fact that location name is a0, a of 0. If I want to access it from outside, the name is a of 0. A of 0 is nothing but this first location, right? So if that first location address I want to store, and that is integer type location, right? That location address, if I want to store in p, I'll get the address of that location by saying and a of 0. This will give me address of this location, which is 4000. I can store it in p. So p is pointing to this location. Now if I increment p by 1, if I increment p by 1 by saying p equal to p plus 1, now p will not become 4001 because p is already 4000. It will not become 4001, but it will be incremented by one location, right? So that means one location is of 4 bytes. So this 1 is nothing but 4 bytes, right? So this is not true. So what it happens is 4000 plus 4, which is equal to 4004. So p goes to, if I do this, p goes to next location, which is this one starting at 4004, right? Now if this location is of, let's say, 8 bytes, and let's say this is double array of doubles, if this, then this location will be 8 bytes, and p is an double type pointer. If you increment p in that case, so p will be incremented by 8 bytes, right? If you say p equal to p plus 1, p will go to, p will incremented by 8 bytes, right? So I hope you got the idea, right? So this concept is very important, very useful. Just to uh, summarize you, if we have a p integer type pointer, int pointer, and if you increment it by saying p equal to p plus 1, right, it will be incremented by p plus one location of integer type. One location of integer type is 4 bytes. That means in fact p will be incremented by 4 bytes. P will be incremented by p plus 4 bytes. If p is a float type pointer, so p will be again incremented by one location, but here one location is of 4 bytes. Again p plus 4 bytes. If p is a character type pointer, and if you say p equal to p plus 1, p will be incremented by one location of character type. That means p will be incremented by p plus, now p will be incremented by 1 byte, right? And if p is double type, if you increment p, p will be incremented by 8 bytes, right? So it's very important concept. I hope you will understand this from this video. If not, please see the video again, right? So now let's see what other operations we can perform on, right? So that is addition operation. You can add an integer to a pointer. Adding an integer to a pointer will move the pointer forward in memory, right, by this much. You should remember this formula, right? And into size of type. This is the type of the pointer. Okay. Similarly, we can perform subtraction operation, right? It will move the pointer in the backward direction, right? p equal to p minus n. Same fashion you can perform this. You can subtract an integer from a pointer, right? Again, pointer p minus p1 is not allowed. It's allowed only in certain cases. Only one case it's allowed. What is that case? We'll see. But this is, in general, this is also not allowed, right? So also you can perform increment operation or decrement operation. Increment means you can say p plus plus, and this is equivalent to saying p equal to p plus 1. That means same operation, adding an integer to a pointer. Here integer is 1. Decrement, p equal to p minus minus, you can say. If p is a pointer, you can say p minus minus, but that is saying same as saying p equal to p minus 1, right? So subtracting 1 from p. So these operations which we can perform on pointers, we cannot perform multiplication, division, any other operation on pointers, right? So in only one case I said we can perform pointer subtraction. That means we can subtract two pointers, right? So for example, and that can be done only when we have two pointers of the same type. That means either integer type, float type, character type, and they are pointing to the elements of the same array, right? Same type pointer and pointing to same array elements, right? Pointing to same array element. These are the two important conditions. In that case, we can perform the subtraction of those 2 points. Let's say p1 is a pointer of integer type, p2 is pointer of integer type, same type, right? Integer, and we have an array. Let's say arr is the name of the array, and this p1 is pointing to 4th element of array. It's storing address of the 4th element of that array arr, and p2 is also pointing to the same array first element, right? So second condition is met. They are pointing to the same array elements, right? In that case, I can say that p1 minus p2, right? In that case, I'll get the difference, the number of I'm sorry, and the result of this is the number of elements in between them, right? For example, so if this is 1, 2, 3 and 4, p1 is pointing here, p2 is pointing here. So in fact, p1 is pointing to first location, p2 is pointing to 4th location. If we do p1 minus p2, p1 is here, and p2 is here. If we do p1 minus p2, in fact we are subtracting the indices. We'll get 4 minus 1. This is 4 minus 1. In fact, we are doing this 4 minus 1, which is equal to 3. In other words, we are getting the number of elements between these two, right? 1, 2 and 3. Number of elements starting from either this onwards or this onwards, back in this side, right? So 3. So we can perform this kind of pointer subtraction. Only pointer subtraction is allowed only in this case, not in general, right? So I hope you will understand these concepts. So see you in the next video. Thank you.